Hello everyone. Today we are going to do a topic from the chapter Numbers, which has a very high weightage in all entrance exams. We are going to discuss everything that you need to know about the factors of a given number. And just like you, I don't believe in memorizing scary looking formulas. So all the examples that I have presented in this video lesson will discuss the actual logic behind those formulas. And I bet once you go through this video lesson, you won't need those formulas anymore. You would be able to solve all such questions as quick as a flash. So let us begin. First things first, what is a factor? Well, a factor is any natural number by which a larger number can be exactly divided. Say for example, we have the number 20. 20 has many factors, which is the same as saying it can be divided exactly by many numbers. And if someone asks you how many factors, try writing the number as a product of two smaller numbers, and each of those will be a factor of 20. So 20 can be expressed as a product of two numbers in the following ways: 1 into 20 or 2 into 10 or 4 into 5. There are 6 factors of 20. Remember, the smallest factor of any number is 1 and the largest factor is the number itself. Then comes the term prime number, which is important for understanding this topic. A number which has exactly 2 factors, 1 and the number itself, is called a prime number. This is the list of all prime numbers that are less than 30. I am sure we just need a cursory revision because we have studied these terms in earlier classes. Moving on, any natural number which has more than 2 factors is called a composite number. And rest assured, the numbers you will face on this topic will be composite numbers. They will have many factors. A composite number is called so because it is composed of many smaller primes. In all the questions related to factors, say number of factors or sum of factors, step 1 is to prime factorize the given number. So that brings me to the question, what is prime factorization and how do we perform it, right? As the name suggests, we need prime factors. So prime factorization is when you write a given number as a product of its prime factors. And the method I prefer the most for prime factorization is called the factor tree method. This is how we do it. Take a wild guess on any two numbers whose product is 20. So 4 into 5 is 20. We write 4 into 5 and we continue breaking up these numbers till we get all prime factors. So 4 is 2 into 2. 2 is prime. We stop here. 5 was already a prime. Now all you have to do is multiply all the primes at the end notes. 20 is equal to 2 into 2 into 5, which is the same as saying 20 is equal to 2 square into 5 raised power of 1. This format of writing down a number as a product of its prime factors is called prime factorization. So let us quickly prime factorize our given number, which is 360. Wild guess on any two numbers whose product is 360? Well, 36 into 10 is 360. Let us break 36 further. 36 is 4 into 9. Further, 4 is 2 into 2. And 9 is 3 into 3. This branch we have 4 primes on the end notes. Further, let's break 10. 10 is 2 into 5. So that is it. Once we have primes on all end notes, we just multiply all of them. 2, 2, 2, we write 2 raised power of 3. 3 and 3, we write 3 raised power of 2 and a single 5. So the prime factorization form of 360 is 2 raised power of 3 into 3 raised power of 2 into 5 raised power of 1. Now let us have a quick recap of this method, which is known as the factor tree method. In this method, we simply write numbers at each step as a product of two or more factors until we get primes at the end nodes. Next, we just need to multiply all primes and that product is equal to the original number. Now, if someone asks you how many factors are there for the number 360, remember, listing down factors of 20 was very simple because it was a small number. In this case, listing down all factors of 360 and counting them will be much tougher. But then, the best part is we do not need to list down all factors of 360. We just need the counting logic for factors. So here it goes. See, in any factor of 360, there will be a combination of these three prime numbers. We can have 2s, 3s and 5s. In any of the factors, we cannot have any other prime number apart from these three, like maybe the number 7. Because 360 is not divisible by 7, none of its factors will be divisible by 7 either. So we can combine the powers of these three prime factors to arrive at the various factors of 360. In any factor of 360, the power of 2 can vary from 0 to 3, which means it could be 0 or 1 or 2 or 3. So the power of 2 can be chosen in 4 ways. The power of 3 can vary from 0 to 2, which means it could be 0 or 1 or 2. So the power of 3 can be chosen in 3 ways. And the power of 5 could only be 0 or 1, that is 2 ways. For example, if we write 2 raised power of 1 into 3 raised power of 0 into 5 raised power of 1, do we get a factor? Yes, we get the number 10. If we write 2 raised power 0 into 3 raised power of 2 into 5 raised power of 1, do we get a factor? Yes, we get the number 45, which is indeed a factor of 360. So by fundamental rule of counting, together the powers of these prime factors can be combined in 4 into 3 into 2, that is 24 ways. And therefore, there are 24 factors of the number 360. Generalizing this concept, let us suppose the given number n can be prime factorized as x raised power of a into y raised power of b into z raised power of c, where x, y and z are the prime factors of n and a, b and c are their respective powers. So for any factor of n, the power of x can be chosen from 0 to a, which means a plus 1 ways. The power of y can be chosen from 0 to b, which means b plus 1 ways. And the power of z can be chosen from 0 to c, which means c plus 1 ways. Together, the powers of the prime factors can be combined in a plus 1 into b plus 1 into c plus 1 ways to form all factors of n. Therefore, this expression gives us the total number of factors of n. And this formula can accordingly be adjusted if there are additional prime factors for the given number or even fewer prime factors. Now sometimes they ask us the number of even or odd factors of the given number. So let us find out how many even factors are there for the number 360. We know how to form factors by combining powers of various prime factors. So just remember, to derive any even factor of n, the minimum power of 2 must be 1. Because if we take 2 raised power of 0, that means 2 is absent in that factor. Power of 2 could be 1 or 2 or 3. 3 ways of choosing that. Power of 3 could be 0 or 1 or 2. 3 ways again as before. And power of 5 could be 0 or 1. 2 ways of choosing. Together, we can combine these possibilities to form an even factor in 3 into 3 into 2. That is 18 ways. So there are 18 even factors of 360. Now, if they ask us the number of odd factors, the logic is again very simple. In any odd factor of n, the prime factor 2 must be absent. That is, 2 must carry the power 0. Power of 2 can be chosen in only one way. Power of 3 can be chosen in 3 ways as in earlier cases, and power of 5 can be chosen in 2 ways as we saw in earlier cases too. So by fundamental rule of counting, together these powers can be combined in 1 into 3 into 2, that is 6 ways. A quick check. There are 18 even factors and 6 odd factors, which add up to the figure 24, the total number of factors. And this is how we can check our calculations. Okay, so friends, whatever we have discussed so far, here is a list of all 24 factors of 360, written in their prime factorization format. As you may verify, the various powers of prime factors combine to form these factors. And in any of these factors, the maximum power of any of these prime factors will not exceed these in the original for the number 360. Let me walk you through some more examples. Find the number of factors of 144. As we know, the first step is to prime factorize this number. 144 is 12 into 12. 12 is 3 into 4. Ditto for this 12. And 4 is 2 into 2. Now we have all primes at the end nodes, the encircled ones. So we multiply them. 144 is equal to 2 raised power of 4 into 3 raised power of 2. Next, we reason out that in any factor of the number 144, the power of 2 can range from 0 to 4. It can be chosen in 5 ways. And the power of 3 can range from 0 to 2. It can be chosen in 3 ways. So 5 into 3. There are 15 factors of the number 144. Next number is 420. 420 is 42 into 10. Further, 42 can be written as 6 into 7 and 6 can be broken down as 2 into 3. Over here, 10 can be written as 2 into 5. Now we have all primes on the end nodes, the encircled ones. So 420 is equal to 2 raised power of 2 into 3 raised power of 1 into 5 raised power of 1 into 7 raised power of 1. In any factor of 420, power of 2 can range from 0 to 2. We can choose the power of 2 in 3 ways. Power of 3 can be 0 or 1. 2 ways of choosing that. Power of 5 can be 0 or 1. Again, 2 ways of choosing that. And the power of 7 can also be 0 or 1. 2 ways of choosing that. Therefore, there are 3 into 2 into 2 into 2. That is, 24 factors exist for the number 420. Our next task is to find out the number of ways of writing n as a product of two factors. So friends, there are 12 ways and 12 happens to be 24 divided by 2. The number of factors divided by 2, isn't it? As a matter of fact, we don't even need to list down any of these ways because our answer will always be number of factors divided by 2. Do you want to know the logic? The number 360 has 24 factors which can be divided into 2 halves. See, these 24 factors of 360 are in ascending order. 12 factors till the number 18 are the smaller ones and the other 12 factors will be the bigger ones. We start writing 360 as a product of two numbers, smaller number first. So we write 1 into 360, then 2 into 180, then 3 into 120 and so on. The 12th way would be 18 into 20. After this, what comes next? The same combination of two factors starts repeating. Next comes 20 into 18. And writing 360 as 18 into 20 or as 20 into 18 It's one and the same thing, isn't it? So we drop the 12 repetitions after this and our answer is 12 ways. Remember, writing n as the product of two factors a and b, where a into b is the same as b into a, the number of ways of doing that is simply equal to the number of factors divided by 2. Few more practice questions. In how many ways can you write these as a product of two factors? The number 144. We calculated earlier that 144 has 15 factors and 15 divided by 2 is 7.5 ways. Well, how can that be an answer? It should be either 7 ways or 8 ways, not a number in between like 7.5. Don't you think so? So let me clear out this dilemma. This happened because any perfect square always has an odd number of factors. So when you start writing 144 as a product of two numbers, smaller first, you will write 1 into 144, then 2 into 72, and so on. And the seventh way will be 9 into 16. Next is 12 into 12, the eighth way. Because 144 is the perfect square for the number 12, 12 is the middlemost factor, the eighth one out of 15 numbers. Before this number, there will be 7 factors and after this also 7 factors. So our answer is technically 8 ways. But let me specify, we can write 144 as a product of two different factors in only 7 ways. Next is the number 420. 420 has 24 factors and 24 divided by 2 is 12. So there are 12 ways of writing 420 as a product of two numbers, or we can say two factors. Now let us move on to the concept of sum of factors. So again, this prime factorization format of 360 is a starting point. Sum of factors of 360 will simply be equal to, and we write 3 pairs of brackets, one for each of the prime factors 2, 3 and 5. In the first bracket, we write all powers of 2 from 0 to 3 with a plus sign in between. In the second bracket, we write all powers of 3 from 0 to 2 with a plus sign in between. And in the third bracket, we write all powers of 5 from 0 to 1 with a plus sign in between. Remember, this is the guide for the maximum power of each prime factor. Next, we just multiply the numbers in these 3 brackets and that is our answer. You would ask me, what's the logic? It's actually quite simple. If you expand these brackets, you will see all 24 factors of 360 written side by side with a plus sign in between. So this is how we get sum of all factors of 360. This number is 1 plus 2 plus 4 plus 8, that is 15. This is 1 plus 3 plus 9, that is 13. And the last one is 1 plus 5, that is 6. 15 into 13 into 6 is 1170. So that is our answer for the sum of factors of 360. Now this simple trick works for any general number n. If n is prime factorized as x raised power of a into y raised power of b into z raised power of c, then for sum of factors, we add up all powers of x from 0 to a, we add up all powers of y from 0 to b, and all powers of z from 0 to c. Then we just need to multiply these 3 numbers. In most textbooks, you are given such scary formulas, but as a teacher, I don't recommend memorizing this. Why do you need to overburden yourself? We can directly do this. This is easier. And besides, this formula is just that of a geometric progression. So as and when you do that topic, you can automatically write this formula if required. Let's try finding the sum of factors for 2 more numbers. 144. The first step is to prime factorize, which we have already done before. So I will just jot down its prime factorization format. 144 is equal to 2 raised power of 4 into 3 raised power of 2. So sum of factors will be, in the first bracket, we write 2 raised power 0 plus 2 raised power 1 plus 2 raised power 2 plus 2 raised power 3 plus 2 raised power 4. And in the second bracket, we write 3 raised power 0 plus 3 raised power 1 plus 3 raised power of 2. So the shortcut for adding these powers of 2 is 2 raised power of 5 minus 1. And the sum of these three numbers is 13. 31 into 13 is 403. That's our answer. Next number is 420. Prime factorization format of this number is 2 raised power of 2 into 3 raised power of 1 into 5 raised power of 1 into 7 raised power of 1. For each of these 4 prime factors, we construct a bracket. In the first bracket, we have 2 raised power 0 plus 2 raised power 1 plus 2 raised power 2. In the second, we have 3 raised power 0 plus 3 raised power of 1 multiplied with 5 raised power 0 plus 5 raised power 1 multiplied with 7 raised power 0 plus 7 raised power of 1. 7 into 4 into 6 into 8 is 1344. That's our answer for the sum of factors. That brings us to an end of this video lesson. If you enjoyed it and found it useful, don't forget to press the like button and also do subscribe our channel IPM Leap. Here is a glimpse of other popular maths videos on our channel. So keep watching. Bye-bye.